The last section in this unit deals with percent change. Percent change is a specific type of percent problem that deals with how much something has increased or decreased. Say, for example, you're looking at the cost of gasoline. If we say that gasoline costs $1.35.8 today, which increased from $1.27.8 yesterday, you might be asked, what is the percent increase? On problems like this, the one piece of information that is missing is the part. Or in this case, it might be better to call that the difference. The difference is a subtraction between what it is and what it was. Don't worry about which goes first, whether the old amount or the new amount. Just set it up so that it's a subtraction that's going to result in a positive number, or if you use your calculator and you get a negative number, just ignore the negative. And you'll see that when we do a subtraction, we get a nice even 8. 135.8 minus 127.8, we would get a 0, and we would get an 8. That's been brought down to a 2, so 8 cents. So this is our part. We're looking for the percent. And somewhere in this question, we're going to have the whole. Well, we've got two numbers in the question we've already used, the 135.8 and the 127.8. And we're going to reuse one of them. And the one that we're going to use as the whole, this is really important, the whole is always the original amount. Take a look at the question. The question's talking about how much gas increased, and so the original amount's going to be your lower amount that it was yesterday. 127.8 was yesterday's original amount, and so that's going to be our whole. Now we're ready to set the question up exactly the same way we have set up all of our previous questions using the fraction method. We've got the part, which is the difference between the two amounts, the 8. We've got the whole, which is the original amount, 27.8. And what we're trying to figure out is what percent, and in this case, percent increase is that. Take your diagonals and multiply. 8.0 times 100, 2 zeros, so move it 2 spots to make the number 800. And then take the 800 and divide it by the 127.8. Definitely going to use a calculator on this one. 800 divided by 127.8. And the calculator says 6.2. And then my next decimal is a 5 followed by a 9. So I'm going to round up to a 6 because it's just going to go on and on and on. Final statement. This is a 6.26% increase. Let's look at one more. Let's say Sue went on a diet. She used to weigh 175 pounds. Now she weighs 153 pounds. And we'll ask, what is the percent decrease in Sue's weight? Well, this is a percent change problem. So to find our difference, which is the part, we would take 175 minus the 153, the amount that her weight changed. So 22 pounds. Now that we've got the difference, we need to find the original in the question, and the original is going to be what we use as the whole. Her weight was originally 175. So don't think about it as which is lower or which is higher. Ask yourself, what was it before the change took place? And in this case, it was 175. Now we'll set up our fractions. The original 175 is our whole. The difference, 22, is our part. And the percent is what we're looking for. So we're ready to solve. 22 times 100. Add a couple zeros because we're multiplying by 100. And then 2200 divided by 175. Grab the calculator. 2200 divided by 175 is 12 point, calculator says 5, 7, and so on. So I'm going to round that to 12.6. So her weight decreased by 12.6%. Next, we're going to look at a slightly different type of percent change problem. Let me write the problem down first. Currently, a cup of coffee at your favorite coffee shop, we won't name any names, is $1.80. Unfortunately, it was just announced that their prices are increasing by 20%. Question is, what will the coffee cost after the increase? Okay, if you take a look at that question, you'll see that how it differs is we don't have the initial amount and the final amount to calculate the difference. What we're given in this question is the initial or current amount and how much it's changing by. So if we look at this 20% increase and think about it for a moment, we know that we're going to be paying 100% of what it used to be and another 20% when the increase is tacked on. That equals 120% of the old price or original price. So we're still always going to use the original. Setting it up, our old price was $1.80. What we're looking for is the new price. And what we know about the new price after we've thought about it is that it's going to be 120% what we were paying before and an additional 20%. Now that we've got it set up, multiply 120 times the $1.80. So 120 times the $1.80 is going to equal 216. 216 divided by the 100 that we see right here is going to be 2.16. And finally, we'll end off by saying the coffee will cost $2.16 or $2.16 after the increase. Let's look at one more very similar to that, but we'll look at a percent decrease problem. A car that you're wanting to purchase is listed at $3,500. This weekend, all used cars are on sale at 15% discount. What is the price of the car if you buy it this weekend? Okay, so you're going to buy a used car. It's $3,500 right now, but if you wait and buy it on the weekend, it'll be a 15% discount. If you think about the current price as 100%, or the word I've been using up to this point, the original price is 100%. If we take off the discount, which is 15%, that's how much it's going to decrease on the weekend, you can see that the new price is going to be 85% of the old price. Setting up our question, the original amount is $3,500. I want to know how much that will be on the weekend when I only have to pay 85% of the price. One too many zeros. 85 over 100. 3,500 times 85. Let's get an answer on that. Is 2,975,000. And then we have to take the 2,975,000 and divide that by 100, and we'll get a final answer of 2,975. So the car will cost $2,975 this weekend. And finally, we're going to look at one last type of problem. In this last type of problem, we're going to be finding the old amount when we know the new amount and the percent change. The last two questions, we were finding the new amount when we knew the old and the percent change. Here's an example. Jill bought a new stove for $485. This was, let's say, 30% discount because it was a floor model. And the question is, what was the original price of the stove? Again, let's see how that 30% relates to the 485. If the original price is always 100% and she received a 30% discount, 100% minus 30% means that she only paid 70% of the original price. So, setting up our fractions, we know that the $485 is 70% of the original price. So if we use $485 as the 70%, we should be able to figure out that unknown piece, which is the original price. 485 times 100 is 48500, and 48500 divided by 70, 48500 divided by 70 is equal to 692.8, and then rounding to the nearest cent, it would round to 0.86. So the original price of the stove was 692.86, or $692.86.